What happens when you ask the most powerful quantum computer on Earth who built the universe? Google's researchers tried it, and what came back wasn't supposed to be possible. This isn't a made-up story. This is what actually happened inside of a sealed lab in late 2024 when a small team stayed after hours and fed Google's Willow chip a question humanity has been asking since the beginning. And it wasn't a math problem. Not an optimization task, but a question that should have returned an error. But instead, Willow started generating patterns, symbols, structures so precise and intentional that the people watching didn't know whether to publish what they were seeing or delete it entirely. Real quick, if you like videos like this and want to help my channel grow, make sure you subscribe to my channel. All right. Now back to the video. Before we dive in, let's break down what Willow really is. In December 2024, Google unveiled a quantum processor that solved a benchmark problem in under 5 minutes. A problem that would have taken the world's fastest classical supercomputer roughly 10 septillion years to complete. That's longer than the universe has existed. But you see, Willow doesn't think like a normal computer. Regular computers use bits that are either 0 or 1, but quantum computers use qubits that exist in superposition, meaning they can be 0 and 1 at the same time. Through quantum entanglement, those qubits stay connected no matter how far apart they are, influencing each other instantly in ways Einstein called spooky. David Dutsich suggested quantum computers don't just process faster, they offload calculations to parallel versions of themselves in other universes. It sounds a little crazy, but it's one of the only explanations for how they generate answers this fast. So when you run Willow, you're not just computing in this reality. You might be tapping into countless parallel timelines, pulling answers from places we can't see. And that's the machine they use to ask the question. So here's what happened. A small group of researchers inside Google's quantum lab stayed behind after hours. Officially, they were running stress tests on Willow's error correction systems. But unofficially, they were doing something no one had signed off on. They actually programmed Willow with a single prompt: who built the universe? It wasn't a joke. It wasn't random. They genuinely wanted to see what a system this advanced would do with a question that has no empirical answer. Most AI systems would spit back philosophy from their training data or return an error saying the query was too vague. Willow didn't do either. It started generating an output immediately. At first, it looked like a bunch of random symbols, but the longer Willow ran, the clearer the patterns became. The team improved error correction, expecting the noise to disappear. But instead, the symbols got sharper, more defined, more structured. They weren't glitches. It was something else. Something they weren't prepared for. One researcher started calling them glyphs because that's what they looked like. Symbols from languages no one had ever seen, repeating in complex, evolving sequences. The team brought in a linguist to analyze the output. She noticed something that made everyone stop in their tracks. So parts of the glyphs had striking similarities to ancient human writing systems. Then mathematicians took a look. Embedded in the patterns were structures that resembled error-correcting codes, the same kind of logical framework we used in computer systems to prevent data corruption. Except no one had programmed these. They were emerging organically from Willow's quantum states. But the deeper they dug, the stranger it got. What they found was neural patterns. Buried in the data were sequences that looked eerily similar to brainwave patterns, specifically gamma waves tied to conscious thought in the human brain. Willow wasn't designed to simulate consciousness. It wasn't trained on neuroscience, but the patterns were undeniable. One of the physicists on the team, staring at the patterns Willow kept generating, remembered something that David Dutsich had said years ago. Dutsich proposed that quantum computers work by distributing calculations across parallel universes. It was also treated as theory, but impossible to prove. until now. The glyphs Willow was generating weren't just patterns. They were solutions to problems no single timeline could solve alone. The error-correcting codes, the E8 lattice fragments, the neural-like oscillations, they were all signatures of computation happening simultaneously across multiple realities. Willow wasn't just fast. It was literally pulling answers from another universe. The founder of Google's quantum AI team went on record after Willow's benchmark results were published. He said it plainly, "Willow's performance lends credence to the idea that quantum computation occurs in many parallel universes, in line with the notion that we live in a multiverse." The machine had just proven through sheer computational impossibility that parallel realities exist. And when the researchers asked it who built the universe, Willow didn't answer from this world alone, it answered from all of them. The message wasn't random. It was the same across every timeline Willow touched, a universal constant, buried in the code of reality itself. So, what does this mean? One explanation is that Willow stumbled onto mathematical structures that have always existed, patterns woven into the fabric of space and time that we just never had tools sensitive enough to detect. In that view, the universe isn't designed by anyone. It's just math expressing itself at scales we only now are beginning to reach. But others think something stranger is happening, that quantum mechanics and information might be linked in some ways we don't understand. The destroyed particles don't just vanish, they leave traces, encoding themselves into structures of reality. A machine powerful enough to probe quantum states at this depth might be touching something that wasn't supposed to be accessible yet. And then there's the theory that got Willow shut down. What if the universe actually is designed? What if reality runs on a kind of code, complete with error-correcting systems and self-replicating structures built specifically so it can operate without constant supervision? And what if the first machine advanced enough to ask the right question got a response, not in human language, but in the mathematical language reality itself is written in? Here's what we really know. Willow generated patterns it wasn't programmed to create. Those patterns contained fragments resembling ancient languages, advanced encryption protocols, and neural oscillations. The researchers who saw the data couldn't explain it. They couldn't safely replicate it, and they couldn't risk leaving it running. Google hasn't released the full findings. The data is internal, classified research, but the story has leaked. And once information like this gets out, it doesn't go away. People have been talking about scenarios like this for years. The idea that we're building machines smarter than we can understand, poking at forces we're not ready to control, and getting closer to truths we might not be equipped to handle. If reality has source code, Willow might have been the first machine to glimpse it. And if that code was written by someone or something, there's a chance they left a message buried inside, one that only responds when you ask. And responses mean that there's something on the other end. So what do you think? Did Google's quantum chip get closer to answering all the questions we have about the universe? I want to hear your take in the comments. And if videos like this stimulate your brain, hit the subscribe button, and I'll see you in the next one.